This week, I'm going to break the oral lectures into chapters, Chapter 9 and Chapter 10. Chapter 9 is actually pretty short and easy to understand, but Chapter 10 is a little bit more involved. So I thought that rather than doing one pretty long oral lecture, that maybe you guys would feel like it would benefit you more to do to have two shorter lectures. And that way, if you have a big chunk of time, then just listen to them both. But if you wanted to break it up more, then you could just do Chapter 9, listen to Chapter 9, maybe do the assessment or work on the project or something, and then do Chapter 10. So we're now entering the third part of the course in terms of the substance, which is hypothesis testing. So you guys should know from hopefully back from research methods that a hypothesis is a prediction, at least from a methodological standpoint. It is a prediction about the effect of one or more independent variables on a dependent variable. And when it comes to the scientific method and using statistics to analyze data, you're looking pretty typically at a deductive research approach, which means that your hypothesis should be rooted in a theory. So we don't just make predictions when we're talking about scientific research. I mean, you as an individual might make predictions. We probably do that all the time in ways that we don't even realize. But when we're talking about from a research perspective, we don't just say, well, I bet that, younger kids are more, they tend to vandalize more than older people. You would need to have that, not to say you couldn't predict that, but if you were going to predict that and actually research it, it would need to be rooted in a theory. In any hypothesis, you should be able to identify the independent variable and the dependent variable and also the level of measure. And if you've been looking at the end of chapter assessments in the Gal book, almost every chapter, possibly every chapter, there are questions asking, what is the independent variable? What's the dependent variable? What level of measure? That cannot be driven enough. It is such a hugely important thing to know and to understand. So obviously to know a level of measure, you would have to know how a variable is operationalized. So if I just said, what level of measure is age? You wouldn't be able to answer that question, because if I gave you categories like age could be, and then what is your age? And you had to circle 18 or under, 19 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45. Those are categories. So it would be ordinal, because remember, ordinal variables are categorical. If I just said, what is your age, and drew a line and everybody just wrote their age, then it would be interval ratio or continuous. Now, some variables like gender, faith group, race, those are always nominal, because even if you did male, female, or I'm not sure, or something like that, or if there was a transgender option or something, that's still nominal. So even though there might be multiple ways of measuring something like gender, or in faith group too, like you might have faith group could be Christian, non-Christian, or you could list a whole ton of faith groups. But no matter how you measure it, it's still going to be nominal. It's still categories. So sometimes, like if I said, I'm going to ask respondents what their favorite flavor of soda is, or what kind of pie they like the most. It doesn't matter how I measure that. It's going to be nominal. So you wouldn't say, well, it depends on how it's measured, because it doesn't. No matter how you measured it, it's going to be nominal. But some variables like age or GPA, variables that can be interval ratio, also can be ordinal if the researcher gives categories. But in any case, just make sure that you can identify the independent variable, the dependent variable, and levels of measure. For example, if I predict that inmates' perceptions of service quality within an institution will negatively affect the number of rule infractions they commit. So in other words, the better their perceptions, or the higher their perceptions of service quality, then the fewer rule infractions they're going to commit. What's the independent variable? And I think about that for a second. Can you answer that question? What is the dependent variable? Can you answer that question? So again, my hypothesis is that inmates' perceptions of service quality within an institution will negatively affect the number of rule infractions they commit. So in other words, the higher or the better they perceive service quality within an institution, the fewer rule infractions they will commit. So the independent variable, hopefully you got, was perceptions of service quality. That's the variable that should affect the outcome. The dependent variable or the outcome will be rule infractions. So now let's say I operationalize or measure the independent variable as a scale of Likert items. Likert is the 1 to 5, strongly disagree to strongly disagree type of scales. So let's say I ask inmates, rate your disagreement or agreement with the following statements. Now keep in mind I'm measuring perceptions of service quality. This institution has good food. Another statement might be, and again, they're rating this 1 to 5, strongly disagree to strongly agree. I received medical treatment in a timely manner. This facility is clean. This facility is safe. So those are different dimensions of service quality that you might measure and ask inmates about. So what is that level of measure? Okay, hopefully you got that it is ordinal. They were ordered categories from strongly disagree to strongly agree. So someone who said 4, that they agreed with those statements, had a better perception of service quality than somebody who said a 1 or a 2. So there was order, but it was not interval ratio because there were categories given. So the dependent variable, let's say so it's rule infractions. I'm going to operationalize that as just the number of rule infractions that each inmate committed. What level of measure is that? Think about it for a minute. Hopefully you got that it is interval ratio. That's a continuous variable. Just how many rule infractions did they commit? Some would have 0, some might have 54. Someone with 20 would have twice as many rule infractions as someone with 10. That's what it's mathematical. It's not just ordered, but there's mathematical meaning behind those numbers. So that's what makes it interval ratio. Your book talks about 2 explanations for there being a difference between means. So if you have mean, you can be talking about the mean of anything, like in this case, rule infractions. Is there a difference in the number of rule infractions that inmates, or in terms of groups, the mean number of rule infractions based on perceptions of service quality? And your book talks about if there is a difference, if there are differences in means, there are 2 possible explanations, assuming you have taken a random sample. That there are 2 possible explanations for this difference. One is just it's sampling error. It's just random white noise. So essentially, the difference that you observe is not a statistically significant difference. It just occurred by chance. And your book talks about like the coin flip example. So if you flip a coin 10 times, you would expect 5 heads and 5 tails. But if you got 6 heads and 4 tails, you wouldn't think anything was wrong. It was just a random fluctuation. With, in this case, the data would be flipping the coin. That's how you're obtaining your data. So it would just be a fluke thing that happened with the particular 10 times that you flip that coin. It's not a big deal. So if you're talking about there being just random sampling error, white noise, then that is not a statistically significant difference. That explanation is what we call the null hypothesis. This is a term you're going to need to know for the rest of the semester. The null hypothesis states that there is no relationship between the mean values on the dependent variable and that any difference that you observe is just a product of chance. So there is no significant difference in the mean values on the dependent variable. If you observe a difference in the mean values, that difference occurred again. It's just random and it's by chance. The second explanation is that the independent variable caused the difference in the means and the dependent variable. If that's the case, then that difference is significant. And that potential explanation is called the alternative hypothesis or the research hypothesis. You also need to know the symbolism. So the null hypothesis is H with a sub-0, so H with a little 0 below it, kind of down to the right of it. And the alternative or the research hypothesis is H sub 1 or H with a little 1. And you can see those designations in your book. So you might see some people refer to it, it's null and alternative, and some people call the null hypothesis and the research hypothesis. The way that you word your research or your alternative hypothesis depends on your variables. So using the example above, my null hypothesis is that there is no relationship between perceptions of service quality in an institution and the number of rule infractions that inmates commit. My alternative or my research hypothesis would state that the better the inmates perceive the service quality, the fewer rule infractions they will commit. The language that we use when we talk about, which is the correct explanation is, do we accept the null hypothesis? Do we reject the null hypothesis? There's certain language that you'll become accustomed to throughout the course. You'll see it on the assessments, you'll see it on your final, you'll hear it in oral lectures, you'll see it in your book. But to introduce you to some of that, you'll hear language like the researcher rejected the null. And if you just think about that, what does that mean? If you reject something, you get rid of it. So if you reject the null, you get rid of the null hypothesis of no relationship. That means your research hypothesis is supported. So if you fail to reject the null, that means you do not reject the null hypothesis of no relationship, which means you accept that, meaning there is no relationship between your independent and dependent variable, so your hypothesis is not supported. So it's not hard language to understand, but if you see something like fail to reject the null, it almost sounds like a double negative, and you need to just kind of think about it for a minute and say, okay, wait a second. If you're rejecting the null, that means we're accepting or you believe that your hypothesis is supported. If you fail to reject the null, that means you're not rejecting the null, you are accepting the null hypothesis, which is saying you believe that there is no difference in the means of the dependent variable based on the independent variable, that any observed difference is just a product of chance, that there's not a relationship between your variables. Now, sometimes researchers are wrong. So you might reject the null and say, my hypothesis is supported, but that might not be correct. And when researchers make that error and say, we're rejecting the null, my hypothesis is supported, that's a type 1 error. Now, if they fail to reject the null or they retain the null and they say, there is not a relationship between the variables when there actually is a relationship, that's a type 2 error. Make sure you know those. And as soon as you know one, you know the other one by default. So if you just remember, when the researcher screws up and in his or her favor, so to speak, and says, my hypothesis is correct, that's type 1. The other one is type 2. The first step in determining whether a research hypothesis is supported is to run one or more bivariate statistical tests. Which test you use depends on the level of measure of your variables. And this is what I've been talking about a couple of times in the past. Make those charts. If this is your level of measure of your independent and dependent variable, what statistical test would you use? And sometimes even researchers have to look that stuff up. What test do I use with these types of variables? Now, we'll typically know the basic like chi-square t-test type of things, but when you get into more sophisticated statistical analysis, and actually I remember when we studied for comps for my PhD, putting together a pretty sophisticated and extensive chart, and we even did include stuff like chi-square and t-tests of just what are the different combinations of levels of measures of the variables, and then what in terms of bivariate, and we got into multivariate statistics, which test would you run given these circumstances or these levels of measures. So I think it would help you guys to do that too. And I was actually also just reading something, maybe I was talking to somebody who, I was talking to this woman, she's fascinating, this attorney who developed this program for probationers. And it's a journaling calendar program where she talks about how probationers write everything down. And I asked her, have you thought about developing an app or putting things online? And she has, but she said that part of the theoretical justification behind her program is the benefit of there's like a brain connection that occurs when we write things down. So I also think that just kind of as a study tip, and I thought, gosh, and I've actually always done that because just on a personal level, when I write things down, it helps me to remember. So that was always how I studied. I would take notes on the chapter, I would take notes and then I would outline from my notes. So I would repeat the information so many times, but the repetition didn't involve just reading it, because sometimes I think you zone out when you read. But by actually focusing and writing it down, I think that it always helped me. And apparently there's actually some research behind that saying, just the act of writing things down is helpful. So hopefully Even if you don't memorize it, just from writing down a chart, it will reinforce what you're learning, and then you'll have the chart to draw upon. So I would recommend doing that. So to determine, the first step to determine whether or not a research hypothesis is supported is that you're going to run a bivariate, meaning just the independent and dependent variable, the two variable statistical test. And then you would need to know, and you will need to know, given these two variables, here's the level of measure of each of those, which test do you use? And that the next several chapters are going to be just that. When you have two categorical variables, you run a chi-square. What is a chi-square? How do you run that? What does it look like in SPSS? When you have this type of variable, independent, and this type of dependent variable, meaning level of measure, then you run a t-test. If you have two continuous variables, you run a correlation. Again, what is that? How do you run it? How do you interpret it? So these next several weeks are going to be focused on the specific bivariate tests that you can run. Remember the three criteria of causation from research methods. One of those criteria was that in order for two variables to be causally related, so going back to my example, in order for perceptions of service quality among inmates to cause differences in rule infractions, the two variables have to be associated. They cannot be causally related unless they are statistically associated at the bivariate level. So these bivariate tests are the first things that you would do to see you're testing for that association. If that bivariate association between the two variables doesn't exist, then you're not going to go further with regression or other multivariate techniques. So some of the bivariate tests that we're going to cover in the next few weeks, I mentioned chi-square, t-test. We're also going to look at analysis of variance and correlations. And these are just different ways to determine whether or not your independent variable and your dependent variable are associated. If they are associated, then you've now met that criteria of causation. Then you as a researcher would run the multivariate statistical tests, which are tests that not, so remember bivariate is two variables, which is the independent and the dependent. Multivariate is multiple variables. So those are tests that include not only the independent and dependent variable, but also the control variables, which are factors other than the independent variable that might explain the outcome. So for example, if we find that perceptions of service quality in an institution is related to the number of rule infractions at the bivariate level, which means your analysis is just including those two variables, and we find that yes, there is a statistical association, then we would run a technique like regression. And we're going to cover regression in the last week of class. And regression would look at the effects of perceptions of service quality, which is the independent variable, and also other things that might affect rule infractions. So if you think about it, like what other things might affect whether or not inmates obey rules in the institution. So maybe it's the crime or crimes of which the offender was convicted. It could be their total sentence length. It could be the time left that they still have left to serve. Inmates that are maybe going up for parole or don't have a whole lot of time left. Maybe they're not going to engage in new or rule infractions, or there's incentive for them to behave. So that could affect their rule infractions. Maybe the number of privileges or the type of privileges they have. Inmates who work might be less inclined to commit rule infractions than inmates who don't work. So you can look at these other factors and we do something called control for those. And that's what we do with the multivariate stuff. But before we get into the multivariate stuff, if there's not even an association at the bivariate level, then you wouldn't even go on to the multivariate stuff. So the first thing you do is this run bivariate statistical type test. And that is what we're going to start with next. So my next oral lecture is actually going to be on chi-square, and then next week we'll move into t-test, and then analysis of variance, which is also a NOVA, and then correlation. And then very much later in the summer we'll get into regression. And regression is actually, at least at the level we're getting into it, it's not as complex, I think, as people make it out to be. So hopefully you won't be too overwhelmed with the tests. Don't worry about memorizing formulas. You need to make sure that you know how to obtain the information to plug into those formulas. So make sure you know like where the appendices are in the back of your book, which ones you use. You'll need to know how, if you need to know the mean for something, you'll need to know how to calculate the mean. You'll need to know how to get it in SPSS, which I showed you in the project description. So you need to know how to get the numbers to plug into the formula. But once you have those numbers, it's as simple as adding, subtracting, multiplying, dividing, and the most complex thing you'll do is take a square root. If you do have questions about how to apply the formula, then let me know, but please don't be overwhelmed by the formula. And in fact, be happy, because a lot of the book chapter space is just going through these same 5 steps that you're going to do for every single statistic. And so it's a lot of space to show you how to do really simple calculations. So if you see a chapter and you're like, oh my gosh, these calculations, they're so overwhelming, they're illustrating essentially the same thing over and over again. And once you have those numbers, it's really basic arithmetic. So not only don't be overwhelmed, be really happy, because it's actually not like these chapters are really dense with just tons and tons and tons of material. It's basically showing you this is the information you need, this is the conceptual foundation, and then they have these statistics in the formula, and then they take a lot of time and space to show you how to apply it, which isn't hard at all. But if you do have problems or you find it confusing or overwhelming, get in touch with me, and I think that I'll be able to talk you through it pretty quick.